Hello, welcome to our channel for probability and statistics. In this video, we will talk about hypothesis testing on variance. We know very often analysts are interested in to test or hypothesis testing the variance against some value, because sometimes people want the variance is sufficiently small before they can start some statistical modeling analysis. So consider the problem of testing the null hypothesis of a single variance, sigma square. So this is the population variance. We want to test if it equals to a specified value, sigma 0 square. So against one of the usual alternative or H1 alternative hypothesis, sigma square less than this value, larger than this value, or not equal to this value. So for the testing of the variance against a hypothesis value, we use chi-square distribution, because we know if the random variable is normally distributed. So this is usually satisfied for the population. So the variance is the second moment of the variable. That's why we use chi-square. So chi-square distribution is the summation of the standard and normal distributions square. So the variables square summation have chi-square distribution if the variable has normal distribution. So for the for the two-sided test, sigma square equal sigma square 0, we use the chi-square n minus 1 s square divided by sigma 0 square. So here, this statistic is square is the sample variance. So we take a sample from the population and we calculate the sample variance. And n is the sample size, and sigma square 0 is the value we want to test against. So this is a specified value. So that's why all these information for the statistic can be calculated. And this statistic has n minus 1 degrees of freedom and has chi-squared distribution. So for the two-tailed test at alpha level of significance, we will look at if this statistic is less than the critical value at 1 minus alpha divided by 2, or this statistic calculated larger than critical value of chi-square distribution at half alpha. We will show this value in later figure. And for the one-side alternative test, we will calculate if chi-square test statistic is less than 1 minus alpha. So note here for the one-tailed test, here is not half alpha, it's alpha. And if we want to test one-tailed test, if we want to test variance larger than a specified value, we will test if the chi-square statistic larger than critical value at alpha. So this is the chi-square distribution density curve. And for the two-tailed test at alpha level, there is a two blue area. So if the test statistic from the sample located in this blue area or this blue area, it will be significant. We will reject H0 and in favor of alternative hypothesis. And these two areas represent half alpha divided by half alpha for each one. For the probability, and this critical value is chi-square at 1 minus half alpha, and this critical value is chi-square of half alpha, right? But for the one-tailed test, either if you want to test chi-square, if you want to test variance larger than a specified value, then this area will be wide. So here is the alpha. So if we just want to look at if the test statistic is located in this critical region, and this value is chi-square alpha, right? And if you want to test one-tail hypothesis, if the variance is less than a value, we just want to look at this area, and here is chi-square 1 minus alpha. And this area will be white, no blue area now. So if calculate test statistic less than this critical value, then the test will be significant. We take a look at an example. A manufacturer of car batteries claims that the life of the company's battery is approximately normally distributed with a standard deviation equal to 0.9. If a random sample of 10 of these batteries has a standard deviation of 1.2 years, do you think that sigma larger than 0.9 year use a 0.05 level of significance? So the solution is, the first, H0 is sigma square equals 0.81. So this is the hypothesis, the value of a standard deviation. So square this will be the variance. So we just hypothesis that sigma square will equal to 0.81. And H1 is alternative hypothesis because the question is if sigma is larger than 0.9. So this is a one-side test. We want to test if this will be rejected or this will not be rejected. So we test H1 is sigma square larger than 0.81. Alpha is 0.05. So the critical region from chi-square table, we can find the null hypothesis is rejected when the chi-square larger than 16.919. So if we look back, this value is for the one-tailed test, and there is no blue area here. All area here is white. So this is one-sided test, and here is alpha. And this value, critical value, is 16.19. So if we get the test statistic from the sample larger than this critical value, then the H1 will be rejected, right? So the test statistic from the sample will have a chi-square distribution with 9 degrees of freedom, and the critical value is 16.919, which will lead 0.05 of the probability to the right of this critical value. Next, we just calculate the sample statistic. The calculation is we just fill in S square is 1.44 because sample standard deviation is 1.2. Then we take square, then N is 10 and chi-square is 16. And you can see this is the one-tailed test. This critical value is 16.919. And we get the sample test statistic is 16. It is located very close to this value on the left side. And the p-value is 0.07. So this test statistic may be here, and take a vertical line, will leave all the area to the right is about 0.07. And decision is, although the chi-square test statistic is not significant at the 0.05 level, However, based on the p-value 0.07 and this test statistic is very close to the margin of this critical value, so we can say that there is some evidence, because here we cannot use the 0 and 1 notion, yes or right, just yes or right. We have to use a somewhat evidence such sigma is larger than 0.9, because this is only one random sample with only 10, right? Sample size 10. So we have to be cautious, not just say yes or no. So can say there is some evidence that sigma will be larger than 0.9. Thanks for watching.